See, in the last class, we just discussed about the classification and Laplace transforms. Now, in this class, we are going to complete the first topic and we are going to see number of questions what I picked. And some topics we are going to learn from questions itself. Okay. Now, we are in the classification of control system. All simple things we discussed already. We are going to discuss one of the very important thing, that is open loop and closed loop control system. Okay. Yeah. What is that? Open loop and closed loop control system. Open loop control system. Open loop control system. What is open loop control system? What is open loop control system? Very simple it is. See, if the control signal, you see here, very simply I'll teach you, very simply I'll teach. Here you have fan at your home. Okay, always my example is a simple example, fan at your home. Suppose if this is the fan, now here you are giving voltage, here this is the input and this fan is giving you output. Then what it could be? It could be controller, speed controller. Yes, I'll write here speed controller. This is speed controller, right? Now that tick knob, speed controller. Here you are giving electrical input with the speed control. If you put it in 5, yes, then this is the control signal. In fact, what is that signal? Input signal. It's a controlled version. This is what? Control signal. This is control signal. But because if this is not there, it is uncontrolled. It is not a control system. Why? Total input is directly applied to the fan. It completely rotates at its full speed if the full input is applied. But I want to control its speed, therefore I kept a controller. Then the signal or the input that is coming out of the speed controller is called as control signal, right? Now if you see, this is the output, now see, very simply you tell me, I want my fan to rotate at 500 rpm, for example 500 rpm. Okay, now whether this is achieved 500 rpm or not, we don't know. Why? When this is possible, see here my input is for 500 rpm, means I am giving voltage in such a way that my fan is going to rotate at 500 rpm, such a way that I am giving input here 500. But this may be 490 only. This may be 490 only. We don't know. If you measure, yes, you are putting tachometer, you are measuring. This is showing it as 490, but you are doing it, right? Why? Because your brain is there, which is acting like a comparator. Yeah, I need 500. Now it is 490. The difference is 10. You are doing it, but on its own, it is not doing. Right? Now, what I do is, just a minute. What I do is, same system I will take. Okay, do understand carefully. Same system. This is a controller. Yeah, speed controller. This is a controller. Yes. Now, just a minute. I think I am clearly visible and audible for all of you, right? Yes, people are trying to enter. Okay. No. See, I am not going to say what is feedback and all right now. We'll discuss about feedback. First of all, let's understand the concept. Okay. Now, this is the input. What you are giving. Now, this is the control signal. Yes. Now, this is your system. That may be fan or lift or whatever it is. This is a system. This is giving us output. Now, this is the actual output. I will compare. How to compare? Get that back. There is a comparator which I am taking. This is the symbolic representation of comparator. Comparison means what? It's a addition or subtraction. Comparison means what? Subtraction. So I am putting plus here, I am putting minus here. Yes, this is the feedback, and I am going to put here something. What is that something, sir? I will tell you. See, this is input is electrical, output is mechanical rotation of the fan. One is electrical, one is mechanical. We want to convert. This is electrical. If you want to compare one electrical, one mechanical, definitely I need to convert this mechanical into electrical. That is possible with help of something called as tachometer. Okay, tachometer. Simply, I'll call this one as feedback. feedback. Okay, yeah, we are feeding back output back to the input. Don't misunderstand, sir. Output is 500. How much we are feeding back? Output practically it is not going. Just output value we are giving it to this comparator so that it will compare. It will compare. It will compare. Right now here you see. Here control signal is depending on only on the input. See, this is controller, this is controller, and this is a system. Just for example sake I taken fan and all. This is a system, this is system, right? Just let me erase, okay. Input, controller, control signal, system and output. Okay, here the control signal is depending upon only input. It is nowhere checking the actual output. That is the definition you have to check, you have to catch. If the generated control signal depends only on the inputs, I am not writing the statement, you can write if you want, but that is a thing you have to remember. If the control signal generated depends only on the input, yes, it is nowhere taking the output into consideration. That is called as open loop control system. Somebody wrote it as feedback and all. Yes, technically you are right, but what is the purpose of feedback? Now you can understand here. Now if you see control signal, this is some signal. Now the difference, see, this is the output, this is converted output. Yes, your output is converted into the input form, converted form of output. Now this is, I can say error. Yeah, I want 500, but this is 490. Now this is 10. Now this control signal is generated such a way that the 10 extra will be given so that this will reach to 500. Suppose if this is 500, 500 minus 500 is 0. Therefore, no control signal goes. System will work as it is. Means no improvement, no increment, no decrement. Right? Now here, control signal generated is going to depend upon both input and output. Yes, let me write. Control signal generated. Yes, I'll write in the next page. Control signal generated depends on both input and output, then the system is said to be closed loop control system. Let me write the definition of open loop control system. Open loop control system, the control signal generated. See, this may be a question, people will ask in the last, sir, in what way question will be asked. Yeah, the control signal generated, depends only on input. What is closed loop control system? The control signal generated, yes, the control signal generated, yes, generated depends on both input and actual output. Right? This is closed loop control system. Sir, an example for open loop control system. What is an example for open loop control system? Example is traffic lights on roads. Yeah, you know traffic lights. You know there is a 4-road junction. If people are there or not there, for every side that they will give same amount of time. Suppose there is a 4-road junction. Okay, generally if full traffic is there on 4 sides, each one will get 1 minute. So for example, I'm saying 120 seconds or 60 seconds. Sorry, 1 minute means 60 seconds. But one side no one is there, other side full of crowd. But is there any such kind of system which is going to measure? No human being is there, no traffic police. But is it automatically going to measure the traffic and going to allot the time? No, such kind of arrangements are not there in India as of now. Example for closed loop control system. Example for closed loop control system is, yes, I can say lift or elevator. What is this? Yeah, you go to lift, you press 5th floor button. It keep measuring how many floors it reached. Yeah, it's not that it is keep on moving and you have to push the stop button. No person will push the stop button. Okay, lift automatically stops in the required floor. Why? Because it's continuously measures what is the input given, what is the output want. Continuously it measures, simply this way, continuously it measures. Now suppose you press 5, now in the ground floor 0, this is 0, 5 minus 0, 5. Yeah, this moves. First floor, yes, this is 1, 4 moves. Now this way it reached to 5. This is 5. 5 minus 5 is 0. Yes, controller input is 0. Therefore, control signal is not there. System will stop working. That way it reaches to its required flow. Now, please do understand which one is more accurate. Yes, which one is more accurate? Closed loop systems or closed loop control systems are more accurate. Let me write the differences. Open loop control system, closed loop control system. See, first point is easy to design. Yeah, no feedback, nothing. Easy to design. This is difficult to design. Yes, instead of difficult, complex design. Yes, complex design. Yes, its design is complex, right? Now, second one is here you see this is less accurate. Means suppose in the way of open loop, if you design your lift, now you are giving input here 5 as fifth floor as input. We don't know whether it is reached to fifth floor or not. We don't know. But here means accuracy is compromised here. Right? So these bits may be asked as questions. Which of the following is more accurate? Closed loop control system. This is more accurate. More accurate. Right? This is more accurate. Now, if you come here, low cost, yeah, its cost is less as the difficulty is less. Therefore, cost is automatically less. Now, here cost is high. Cost is more, right? So these are the here if you want no feedback here, there will be a feedback will be there, feedback is present. Okay, feedback is present, right? These are the core differences between open loop and closed loop control systems, right? Yes, any question till now? Any question? See, stability we will discuss later. Stability doesn't depend upon, I can say, sometimes open loop is unstable, closed loop is more stable. That depends on how we are going to apply the stability. I can say feedback. Okay, that depends. It's not that open loop are more stable, closed loop are less stable. That point is completely different. In what way? Suppose if you take one system that is open loop system which is stable, if you apply feedback to that, then there is a possibility of reduction in the stability. Yes, if you want, this way I can write. See, suppose if you are taking an open loop control system. Yes, fifth point. See, you are taking one system. Okay, it is more stable. It is stable first of all. If you apply feedback to that, if you apply feedback to the same system, then there is a possibility for the reduction of the stability. Okay, what is stability and all we'll see in the stability chapter, not now. Okay, sometimes there is a possibility to improve the stability also. That's why I did not take in this point. Simple example I'll take. Suppose 10 by s minus 1 is there. This is open loop. Where its pole is there, what is its characteristic equation? S minus 1 is equal to 0. Where its pole is there at s is equal to 1. S is equal to 1 means right side. If pole is there in the right side, system is unstable. Yes, it is unstable. Now, if I apply feedback to this, I am going to apply unity feedback. Means nothing is there in the feedback, only 1 is there. Nothing is there, that is called as unity feedback. Now its transfer function will be 10 by s plus 9 you get. How to get that I will discuss today itself. Now what is its characteristic equation? S plus 9 is equal to 0, s is equal to minus 9. Now the pole is there in the left hand side which increase its stability. That's what I am saying. If you properly apply, then no problem. If you are not applying properly, stability will reduce. So it means there is an unstable system that became stable if you apply feedback, negative feedback, that too properly, then its stability will be improved. Stability will be improved, right? I hope people are able to catch. Yes, but already stable system is there. Stable open loop system is stable. If you apply feedback, feedback may reduce the stability. Okay, there are chances of reduction. There are chances of reduction in stability. Yes, its stability may be compromised if you won't apply properly. If you won't apply properly, right? So these are the points. Then let's talk about something called transfer function, which is very, very important for us. See, there is a system. There is a system. It may be any kind of system. Okay, it may be any kind of system. The mathematical function in S domain which represent that system is called as transfer function. Okay, don't think much about it. Okay, what is that, sir? Let us give input r of t in time domain. Its Laplace is r of s. Then we are going to get output c of t in time domain. Its output in frequency domain is c of s. Then transfer function. Yes, as it's the first time, I'll write completely. After that, t dot f. That's all. Transfer function simply t dot f is equal to Laplace transform of the output by, yes, Laplace transform of the input. That is Laplace output means, see, output means always must be in time domain. Sir, if it is C of S, we must call it as Laplace transform of output. Okay, Laplace transform of C of t by Laplace transform of R of t. So that is C of S by R of S transfer function is. Okay, sir, why it is useful for us, how it is useful for us, all those things I'll discuss. Please first look at that carefully. Look at that carefully. Yes, I request all of you to understand that part. Right? Transfer function is equal to C of S by R of S. People will misunderstand the transfer function. Okay, I'll discuss about it. Transfer function is very important. Entire control system will run on the topic transfer function. Okay, suppose it's a pen. I want to find its length. What I'll do? I use a scale. Suppose I am using Camel company scale. Somebody using some other company scale. Sir, why we perform operations of system? Just a minute. Somebody is having some query, it seems. Uh, in S domain. Okay, see, uh, simple. Okay, somebody is asking, sir, why we do entire operations in S domain. Suppose, see, there are a lot of things, but your BL does not require that depth. That's why I'm not taking. Suppose my input is Vi of t. Okay, current is I of t. Now let's write KVL for this loop. What do you get? Minus Vi of t plus R into I of t plus L di by dt. L di by dt. What is this equation, man? Mr. Ohm? Mr. Om asked one question. Yes, that's very good. But as I'm telling, I can say your BL does not require that much depth. That's why I'm not taking. But it's okay. This is what equation? Differential equation. It's not algebraic equation. Differential equation is going to have two solutions. One is complementary function, another one is particular integral. It takes quite a lot of time, lot of methods, blah blah blah. If you apply that to the same, if you apply Laplace to the same circuit, if you apply Laplace, this is R. L is no more L. L is Ls. You remember resistance is R in S domain, inductance is Ls, capacitance is 1 by Cs. Okay, now this voltage will become Vi of S, the current will become I of S. Now write the KVL, minus Vi of S plus R into I of S plus Ls into I of S is equal to 0. Now you see, what equation is this? What equation is that? Tell me. That's an algebraic equation. Okay, see, this is a differential equation which is very difficult to solve. This is simply algebraic equation. Yeah, if you want I of s, simply I of s is equal to Vi of s by r plus ls. Directly you get. Apply inverse Laplace, you get the answer whatever you want. But here you want to solve this one complementary function, particular integral, and somewhat it is very difficult to solve all kinds of differential equations also. That is also one of the problem. Okay, suppose if the differential equation is going to have functions like tan h, okay, very difficult. That's why this is the reason why we go for S domain. Okay, for everything we have reasons. Okay, without reason nothing will I can say we discuss. Everything is having its own reason to discuss, but now I'm not taking into that depth which is not required for you. Okay, transfer function is equal to C of s by R of s. Now I'm there at this example. I want to find its length. I'll take some camel company scale. I get some 11 centimeters like that. Okay, I change the company of the scale. Is there any change in its length? No. Why I'm discussing that point here, I'll tell you. Now, if you take any system, its transfer function, to find the transfer function, we will take the help of Laplace transform of output and Laplace transform of input. But this transfer function does not depend upon this value and this value. You may be thinking, sir, in what way it is not dependent? Tell me, all of you, there is a resistance of R ohms. I am applying a voltage of V, a current of I is flowing. So V is equal to I into R. From this one, R is equal to V by I. R is equal to V by I. You tell me, if voltage increases, what about this resistance? You tell me, all of you. If voltage increases, what about the resistance is my question.
No change. No change.
No change. No change. People may think, sir, voltage is increasing, resistance has to increase. No. Suppose you tell me, you purchase some 2 ohm resistance. If you apply more voltage, it is going to become 3 ohms. No, it is never going to happen. If voltage increases, obviously current also is going to increase in the same proportion, and resistance is constant. In the same way, transfer function is fixed irrespective of this input and output. As I told you, you're using camel company scale, other company scale. So those are like this. If this changes, this also will change in the same manner. Suppose if this is doubled, this also will get doubled, then transfer function is going to remain constant. Transfer function is going to remain constant. Right? Yes or not? Yes. That is what transfer function is. Some points related to transfer function I'll take up now. The very first point related to transfer function is, see, system must have zero initial conditions, means there should not be any energy, previous energy in the system, then only you can apply transfer function. Okay, first of all, transfer function is applicable for LTI systems, linear time invariant systems only. Transfer function is applicable for LTI systems only. Second one is transfer function is valid for systems with with zero initial conditions, or zero initial conditions. This also called as system at rest. System at rest means which is not having any initial energy, right? So third point is system at rest or initially relaxed system. Sometimes he say. So this can be formed as a question for you in the exam. Okay, transfer function method of approach is not applicable in which of the following cases? 3 options or 2 options he'll give. After that, combination of the options. In any manner you can find the options. If you have the clarity in the concepts, you can easily answer, right? Now next point is it is applicable for transfer function is used for single input single output systems only. Single input single output systems only means if a system is having only one input and one output, then only you can apply transfer function method. Otherwise you can't apply transfer function method of approach. Okay, these are the 3 points which must be checked before you apply transfer function. System must be linear. I told you what does it mean by linear, which must satisfy superposition and homogeneity, right? Now let me derive a general transfer function, generalized transfer function. What is this? I will tell you. I'm taking a system, okay, I'm taking a system, general system, okay. This is g of s. Sir, what is this g of s? There are few equipments. All those equipments mathematically in S domain are represented as g of s. I'll take you back. I'll take you back to the slide where we were discussing. Yeah. Now this one is having some mathematical function. This one is having some mathematical function. Both I multiplied in S domain, and I got something. I'm naming it as g of s. That's all. I'm naming it as what? G of s. Okay, that is g of s. Come here. G of s. In the feedback, whatever I kept, I am calling it as h of s. You know one thing. See, there are now. Tell me, what kind of feedback is this? This is input r of s in S domain. This is output in S domain c of s. Okay.
Negative
What kind of
feedback.
feedback? It is negative feedback. See, do remember one thing. Negative feedback is mostly preferred because of its advantages. So negative feedback is having some advantages. So those advantages I'll discuss. Okay, in terms of problems or questions, objective questions, I'll discuss the advantages of negative feedback. Now you tell me output is c of s, input is r of s. Just some small block diagram algebra I'll perform here. Algebra, you know about algebra very well. Okay, all of you, simply I want c of s by r of s, c of s by r of s in terms of g of s and h of s. Why, sir? G of s and h of s belongs to a system, means this is a pen. Its length, see, this is consisting this orange color strap, this white color knob, and a lot of this g of s and h of s are in this. Okay, this way you can take. This belong to system. Now you tell me, if g of s changes, obviously transfer function will change. If r of s changes, transfer function is not going to change. If r of s changes, proportionately c of s is going to change, your transfer function will remain same. So transfer function depends upon g and h, which are called as system parameters. Okay, one more point here. Yeah, I'll write fourth point. Transfer function depends on, yes, transfer function depends on system parameters, on system parameters, but not on input and output, but not on input and output, right? But not on input and output. Now transfer, see, I told you I'm going to perform some algebra. What is algebra? I'll tell you very fastly. I'll do. Okay, that is very simple. Okay, don't think that sir is going fast. My pace is not fast. Why? Because simple fundamental basics. Okay, now tell me, there is a motor which is running, there is a motor which is rotating. Suppose somebody is measuring speed. I also came, I measured its speed. Somebody also came, they are measuring the speed. Same motor, therefore all three will get the same answer or different answer. Same meters, all meters are working properly. All three will get the same answer or different answer. Come on, same
Same.
answer it should be. In the same way, why I taken that example is, here this is the output here, c of s. Okay, that is going forward. Now I am measuring its value. I am not taking it. Taking is different and measuring is different. Suppose there is a cashier in bank, that fellow will measure the cash. He is not going to take. Okay, yes or not? Here also, this feedback, suppose if this value is 100, that value 100 is noted and that is compared here with the input, so that necessary action can be taken in hundreds or 20 in network analysis. No, suppose sir 10 amperes is coming, there is a junction or node, some 2 amperes is going this way, then remaining 8 amperes will go. That is network current. This is at a junction, current will divide. This is no more current, that is a signal. Here I am taking the feedback. This is called as takeoff point. Takeoff means from there I am taking it, means I am measuring it. Okay, part of it is not taken. So therefore, how much is this also value wise? This is also c of s. Here a lot of students will get confused, sir. Oh, this is c of s, this is c of s, this is c of s. Actually this is c of s, the same value is going forward, but its value has been measured here as c of s, right? Now what is this one? This one will be c of s into h of s, na? Yes. Come on, c of s into h of s. Now how much I get here? Let's name it as error e of s. Now can I write e of s is equal to r of s minus c of s into h of s? Can I write?
Yeah.
Yes. Simple algebra. Yes or not?
Yes, sir.
Come on, man. Reply me.
Yes,
Hello.
sir.
Yes, sir.
Yes. Now, can you tell me what is C of S? C of S is equal to E of S into G of S. Tell me, will you accept this one or not? Yeah. C
Yeah.
of S is equal to E of S into G of S. E of S is equal to, this is the input with plus R of S plus R of S, minus with minus, this C of S into H of S is coming. Now substitute out there. Here this E of S you substitute out there here. Okay, C of S is equal to, yes, what is E of S? R
R
of
of S minus
S minus C of
that
S
was
into H of S into G of S into G of
G of
S.
S.
Now what I want, our aim is to find the transfer function which is equal to what? C of S by R of S. C of S by R of S in terms of G and H. Now what to do? Here C is there, take to that side, take that side. Okay, just let me add some pages here. Let me add some pages out there. Yeah. Now C of S plus C of S into, yes, C of S into G of S into H of S. Yes, G of S into H of S is equal to R of S into G of S. Observe, R of S into G of S. Now take C of S common, 1 plus G of S into H of S is equal to R of S into G of S. Now C of S by R of S is equal to G of S by 1 plus G of S into H of S. You must remember this general transfer function. Now, G of S is having one fancy name. What is that? Forward path function or forward path transfer function. Means what? Forward path means the path taken from input to output. Yeah, when you are moving from input to output, the function you are encountering, RFS and CFS are not functions, they are variables. They are not system functions, they are variables. When you are moving from RFS to CFS, you are encountering this G of S. That's why the path taken from input to output is called as forward path. Point number one. In that path, you are encountering something in a box. Okay, that is called as forward path function or forward path transfer function. H of S is called as feedback path transfer function. Yes, H of S is called as what? Feedback path transfer function. Right. Now, sir, now let me write the transfer function here. Transfer function is equal to C of S by R of S is equal to G of S by 1 plus G of S into H of S. Which feedback we taken? Yes, which feedback we taken? Yes, tell me. Negative feedback. Suppose if I take a positive feedback here, yeah, this will change. Means here
If
I can write here in the diagram minus for negative feedback, plus for positive feedback, but in the transfer function it is exactly opposite. So I can write here plus for what? Negative feedback, minus for what? Positive feedback. Plus for negative feedback, minus for positive feedback. Right? Suppose, sir, H of S is 1. If H of S is equal to 1, that is called as unity feedback system. If H of S is equal to 1, then the system is called as, yes, what? Unity feedback system. If it is unity feedback system, it is quite easy. First, what is the transfer function? Transfer function is equal to C of S by R of S is equal to, come on, G of S by 1 plus or minus, plus for negative feedback. In the transfer function, as I told you, it is exactly opposite to the terminology. Plus for negative feedback, minus for positive feedback. 1 plus or minus G of S into H of S, but H of S is how much? 1. H of S is 1. Right? See, one you remember, remaining everything you'll get. right? Now next thing that we are going to get, that is very crucial. See, somewhat control systems, in control system there are few things which are quite opposite to the things, or quite different, or not opposite, quite different. Octa means how much? 8 in your language, but in control systems in board it is going to be 2 times, not 8 times. Okay, here also, why I taken that example here, so that I want to convey something over here, that is open loop transfer function, open loop transfer function. Now tell me, first of all, this is what this is called as closed loop transfer function. Why it is called as closed loop transfer function? This is the transfer function of the entire system. Sir, why initially only you did not wrote closed loop transfer function? You forgot? Are you making changes now? No. If this is not mentioned closed loop term, by default it is closed loop transfer function only. Suppose if I say 10, so is it required for you to me to represent explicitly as plus 10? Not required. 10 means plus 10 only. If it is minus 10, then explicitly I'll mention it as minus 10. Right? I think you're getting. In the same way, transfer function means by default it is closed loop transfer function. If it is open loop transfer function, he will mention explicitly. Otherwise, he will mention as only transfer function. Then you have to treat it as closed loop transfer function. That's why knowingly I did not wrote. Okay. Yes. Now come here. What does it mean by open loop transfer function? Open loop transfer function means, don't think that, sir, let us remove feedback. Let us remove feedback and get the transfer function. No. Open loop transfer function means in forward path whatever you have, that into in the feedback path whatever you have. Don't misunderstand the term open loop. Open loop doesn't mean to say to remove the feedback and get something, get that transfer function. Yes, g of s into h of s. Why I given this pause, so that you will register this one in your mind. If it is unity feedback system, if it is unity feedback system, tell me, then what is your open loop transfer function? Open loop transfer function is equal to simply g of s, na? Why? H of s is 1. That will become what? Simply g of s. G of s. Now, something we have to take, that is, what is a closed loop transfer function formula? Closed loop transfer function is equal to g of s by 1 plus, see, this is exclusively for unity feedback system. UFB stands for unity feedback system. Unity feedback system. G of s by 1 plus or minus, plus for negative feedback, minus for positive feedback. 1 plus or minus g of s, actually into h of s should be there, but as it is unity feedback system, means what? H of s is 1. Now you tell me, what is the OLTF? OLTF is equal to g of s into h of s, but h of s is 1. Now, can I write CLTF is equal to, yes, g of s is what? OLTF by 1 plus or minus OLTF. Observe it, understand it, digest it. Yes, next I'm going to give you one question there. Okay. Right, CLTF is equal to OLTF by 1 plus or minus OLTF, plus for negative feedback, minus for positive feedback. Now let me give you a question. Answer please. Answer that question please, all of you.
C.
Yes, very good. Option is C. Yes. Yeah, the answer is very simple. Answer is very simple. See, those people who are saying that, sir, your pace is fast, and for that only, just I was waiting so that go back. Okay, answer is C. A. Druvali A. Darshini A. Deepika C. Pradhan C. Anshul C. Okay, good man. Most of you C. Very simple. First of all, unity negative feedback system, what we got? CLTF is equal to negative feedback, na? OLTF by 1 plus OLTF. 1 plus OLTF. Very simple. 1 by S by 1 plus 1 by S. That is equal to 1 by S plus 1. That's all. Very simple. Why it is A? It is not A. It is C. Right? Then let's let me give next question. Let me give next question. The OLTF of an unit, not OLTF, let me give CLTF this time. The CLTF of an unity negative feedback system, UFB, I write, okay? UFB is, I can say, 2 by S plus 2. Then the OLTF is dash. Unity negative feedback, UNFB, not just unity feedback, unity negative feedback. Unity negative feedback. Then the OLTF is dash. Options are 2 by S, 2 by S plus 1. Option C is S by 2. Option D is 2 by S plus 4. Answer please.
A.
Answer. Array man, somebody is trying to enter into the class now. See, it is always request to enter into the class in time so that you'll miss na. Option is D. People are saying Siri saying D. Okay, let me D A D. Okay, answer is absolutely A. Absolutely A. Hauser. CLTF is equal to OLTF by 1 plus OLTF. Are you unable to solve this? CLTF how much is given? How much is given? 2 by S plus 2. This one OLTF by 1 plus OLTF. Solve it, that's all. Solve it, that's all. So take this one to that side, nothing. Just so you'll get OLTF as, I'm writing the answer directly. OLTF, you're going to get it as 2 by S. You can check. Solve this, you will get. Solve this, you will get. Okay? Yes or not? Then let's go to the questions. Or before going to the question, I want to teach you something that is poles and zeros. If you take a transfer function, yes, some s plus 1 by s plus 2, s into s plus 2 into s plus 3. This way it is there. Okay. Now, first of all, transfer function I wrote. You tell me whether it is closed loop transfer function or open loop transfer function. Tell me. It is closed loop transfer function. As I told you, by default, any given transfer function, if nothing has been mentioned, it is taken granted as a closed loop transfer function. The denominator of the closed loop transfer function in the form of equation is taken as the denominator of the closed loop transfer function in the form of equation is taken as characteristic equation. C dot E stands for what? Characteristic equation. Now the roots of the characteristic equation, yes, it is having 3 roots. What are the 3 roots? S is equal to 0, S is equal to minus 2, S is equal to minus 3. These 3 are the roots. These are called as poles. These are called as what? Poles. How poles are represented? Poles are represented. Explain, na? S is equal to what? Sigma plus j omega. S is equal to sigma plus j omega. Sigma is the real part and omega, j omega is the imaginary part. Omega is the imaginary part. Now it is having 3 poles. One pole is at the origin. Pole is represented with cross symbol. Don't enter. Okay, cross symbol. Why? If you put the pole value, transfer function will become infinite, which is practically not possible. That's why, yes, this is minus 2 and this is minus 3, right? If the numerator, see, numerator of any transfer function equal to 0, s plus 1 is equal to 0. Let me write here. S plus 1 equal to 0. From this one we get s is equal to minus 1. If I put this minus 1 again in this one, minus 1 plus 1, how much it is? 0. 0 anything is what? 0. That's why that is called as 0 of the transfer function. 0 of the transfer function. Just look at it once. Look at it once. Right? Denominator equal to 0 gives you poles. Numerator equal to 0 gives you zeros. Yes or not? Yes. Now, so this is how we denote poles and zeros. Now come here. I'm giving next. Let me go for the next topic. Suppose I'm taking a transfer function like this. If this is a transfer function, suppose its numerator is s plus 2, denominator is s plus 3 into s plus 4 into s plus 5. S plus 2 by s plus 3 into s plus 4 into s plus 5. Right? It is having, see, numerator zeros. Okay, how many are there? 1 is there. Poles, so let's take it as z. Poles are how many are there? Poles are how many? 3 poles are there. The poles which are visible to our eyes, The zeros which are visible to our eyes are called as finite poles. Finite poles and finite zeros. Finite zeros, finite poles. I need to mention explicitly finite term. Then what he says is 3 poles are there, na? 1 0 is there. He says if poles are 3, zeros also will be 3. I repeat, always poles and zeros are equal, but it is not here. He mean to say there are 2 more zeros which are not visible to you, which are there at infinity. So here, number of zeros at infinity, number of zeros at infinity is equal to, how many are there at infinity? P minus Z. Yeah, P minus Z. Sir, if it is reciprocated, more zeros, less poles, then you'll find number of poles at infinity, if zeros are more than poles, Z minus P. When this is correct for all P greater than Z. This is for all Z greater than P. This is for all what? Z greater than P. Right? That is one of the concept I thought of discussing. Next, very simple, before we entering into the questions, one simple concept I want to discuss.
You repeat that.
Yes.
Sir, explain how to calculate zeros and poles.
Yes. You are not audible, ma, clearly.
Sir, explain how to calculate zeros and poles.
Okay. Which you are asking about finite or infinite?
Both.
Both. Okay. See, visible to us very clearly. How many are there? 3 poles, right? 1 0. Those are finite poles and finite zeros. Generally, poles and zeros. Need not to mention the term finite. But what the scientist says is, brother, how many poles are there? 3. Number of zeros also should be 3. But only one is visible. He is saying us that there are 2 more zeros at infinity. Those are called as number of zeros at infinity. How many poles are there? 3 poles. How many zeros are there? 1 0. Finite. P and Z are what? Finite poles and finite zeros. See, this is finite zeros. These are finite poles. So let me write. Finite poles. Finite poles. P. How many? 3. Finite means which are visible, which are there really. Infinite means which are not there, which is our assumption or scientist assumption. Okay. Now, here poles are more, zeros are less. Therefore, that difference 3 minus 1, zeros will be at infinity. Whichever that is less in number, that less number will be there at the infinity. Right? Number of poles at infinity, Z minus P, if Z is greater than P. Tell me, any clarification if you want further, I'll explain further. Or why further explanation? Let me give an example. So transfer function is equal to s square into s plus 3 cube by s plus 1 into s plus 2. Now tell me, how many finite zeros are there? Finite zeros.
5.
5. Yeah, numerator is nothing but zeros, denominator is nothing but poles, I told you. Numerator is zeros, denominator is poles. How many zeros are there? 5. Yes, 5.
Sir, explain how 5.
Come on, ma, s square, square 2, s plus 3 whole cube 3. Third order, na? Come on, you tell me, x square plus 2x plus 1 is equal to 0 is going to have how many roots, ma? Is going to have how many roots?
2.
2 roots. Second order, na? X square. Suppose if I take x cube plus 3x square plus 2x plus 1 is equal to 0, how many roots? 3 roots. Highest order will be the number of roots, na? Mathematical simple fundamental from 10 plus 2. Okay. Now, if you observe carefully, here s square 2, s plus 3 whole cube 3, 3 plus 2, 5. Number of poles, how many are there? 1, 2. Yes, whole power 1, whole power 1, total 2. Now, which are more? Zeros are more. If zeros are more, then we can say that poles are existing at infinity. So, number of poles at infinity, number of poles at infinity is equal to z minus p. Z is 5, p is 2, that is equal to 3. Right? Hello?
Yes,
Yeah.
sir.
Any question if you have, you can ask. I'm there here, ma. Any question is there, you can ask. Okay. Right. Let's go for one more simple concept. Now, simple, let me take one question. Okay. The unit, okay, unit means one. Unit step response. Unit step response of an unity negative feedback system is e power minus t into u of t. Then find first one, closed loop transfer function. Second one, open loop transfer function. Please try it. I know that you can't do, as it is the very first question of that kind. You can't. I know that you can't do, but try it. Anyhow, in 1 minute, I'll take it up. Yes, I am waiting. Yes. Answer, please. People are trying to enter now. Okay. So I request all of you to attend the class in time. See. Here, sir, he given something, whether this is input or output. Okay, if that is input, then where is the output? Suppose if that is output, where is the input? Very simple. He's saying the unit step response, break this. The unit step, this is the input. Means he's saying when the input is unit step, the response obtained is this one. Okay, if you are not understanding that statement, you never can answer this question, this kind of questions. The unit step response means whenever unit step has given as input, then the response obtained of a unity negative feedback system is this one. Then what is transfer function? Very simple. Transfer function is a Laplace transform of output. Yes, this is the output. E power minus t into u of t by Laplace transform of input. What is that? U of t. Yes. So transfer function is equal to, what is e power minus t into u of t? 1 by s. U of t means 1 by s, minus 1 means plus 1. By u of t means 1 by s. You get what? S by s plus 1. Yeah. What it is? S by s plus 1. What is this? Transfer function means what? It is by default closed loop transfer function, as I told you. Whenever you get any transfer function from any given circuit or from the given data in time domain, that is always closed loop transfer function. Then how to get the open loop transfer function? You know it very well. Open loop transfer function, you know it very well. That is OLTF is equal to, yes, CLTF by 1 minus CLTF. Do remember this formula. You may be thinking, sir, from where you got this formula? We know that CLTF is equal to OLTF by 1 plus OLTF for negative feedback. You operate on this. Sir, what is the operation I have to do? CLTF into 1 plus OLTF is equal to OLTF. Now segregate it. CLTF plus CLTF into OLTF is equal to OLTF. So take that OLTF part that side. Then you get it. You're going to get this one. For negative feedback, these two are valid for what? Negative feedback. For positive feedback, just you have to put the exactly opposite relationship. Exactly opposite relationship. Here you put a minus, there you put a plus. Yes, you can see the last one step I left it to you. Take this CLTF into OLTF part to that side, then take OLTF common, then you get 1 minus CLTF, send that one to this side, then CLTF by 1 minus CLTF. Simple mathematical. That is algebra. Nothing means no sum, no magic, no nothing, no logic also. In fact, just simple fundamental algebra, right? Now, for today, I'll stop here. There are a lot of questions we discussed, okay, today. And in this document, I'll send it to you. There are a lot of questions in this topic which I added. You can easily answer all the questions from that topic. If there is any question which you are unable to answer, then definitely in tomorrow's class in the evening at 6 p.m. I will be discussing. You have, all of you have my number. If you are not getting, see, if you are not getting any answer, then you message me. Don't say, sir, I got this answer. Okay, there also same answer is there. So if same answer is there, if you are clear with the concept, you need not to message me. Okay, if you have any, see, I'm telling you, if you have any doubts, straight away you can call or message me. But just for your satisfaction purpose, don't message me. Okay, why? Because I need to allot time to other students also who are really preparing. Okay, thank you. We'll meet tomorrow at 6 p.m.